Hello, everyone, and welcome to The Vertical Space, a podcast at the intersection of technology and flight. We are your hosts, Jim Barry, Peter Shannon, and Luka Tomjanovic, and here we look at the most important forces shaping the market of advanced air mobility with a particular focus on why and how they matter to those building a business in this very exciting and growing industry.
So there's really going to be a need to exchange that data, track data, intent data, and so forth, so we can all live together more efficiently. Can you imagine the airline industry if everybody was separating themselves and the only way that they would change the track is if they got a TCAS warning that says turn right and descend immediately? Same thing in the drone community. It wouldn't be very efficient if you were operating, let's say, drone delivery service and didn't know that somebody else was out there and you're altering your course multiple times to avoid these other vehicles. I mean, at some point it would be, you'd stretch the system too far. But if the other guy knows there's somebody here and we can figure out a way to share better, I think that makes a lot of sense. This airspace is finite. It's big, but it's finite. And we have to figure out a way to share it with everybody in a much more flexible, much more dynamic way.
Hey everyone, on a day after an earthquake here in the Northeast, welcome to the Vertical Space podcast and a discussion with Lorne Cass, an aviation executive who most recently served as Vice President of American Airlines Integrated Operations Center and is the current RTCA Chair. Lorne knows where aviation has been, where it is today, and talks about how he believes we're going forward in aviation. You'll enjoy Lorne's overview of the aviation industry, airline operations, the challenges faced by airline operations, and few can tell you better about the opportunities available to our innovators facing not just tomorrow's challenges, but today's opportunities for near-term operational optimization. Innovators and their investors should take note. There are so many opportunities for innovators from Lorne's discussion, starting with where he believes few agree with him on, to the challenges airlines and airports face today, to the requirements of today's and tomorrow's operators, to the challenges and opportunities of air traffic optimization, and to the requirements and opportunities for data sharing and coordination in our complex airspace. Something that would be fun to hear what some of today's leaders in traditional aviation and advanced air mobility discovered from Lorne's discussion and from some of the other conversations with other guests we've had on the podcast that talk about today's aviation challenges and opportunities and how current conditions may or may not impact how drone delivery, UTM, and other advanced air mobility OEMs, operators, and investors think and plan for the future. So with all that said, many thanks to Lorne for a terrific discussion, and to our listeners, we hope you enjoy our discussion with Lorne Cass as you innovate for today's and tomorrow's opportunities in the vertical space.
This episode of the Vertical Space podcast is brought to you by Avionics. Avionics is the leader in low size, weight, and power certified avionics for manned, unmanned, and advanced air mobility aircraft. Let Avionics help you achieve your goals, whether that be type certification, airspace access, or beyond visual line of sight operations. Avionics has certified and certifiable communications, navigation, and surveillance avionics for your aircraft. So head over to uavionics.com or Google it to see how you can start flying safer and move your platform forward into shared airspace.
Lorne Cass is a seasoned aviation professional with extensive experience in both public and private sectors. He currently serves as president, Aero Nowgen Solutions, and a co-founder, Dynamic Airspace Solutions. Lorne began his aviation career as an air traffic controller with the FAA, and moved on to the airline industry where he served in operations leadership roles at KLM, Northwest Delta, and American Airlines, eventually serving as Vice President, Integrated Operations Center, leading the integration of the post-merger American U.S. Airways Ops Control Centers. Industry leadership roles have included serving as co-chair of the FAA Industry Collaborative Decision-Making Initiative for 8 years. Lorne is a strong supporter of the future info-centric NAS, which will rely on next generation of CDM with robust and reliable exchange of data at its core. Lorne has long been a participant in consensus-built aviation standards development, including R&P, surface, and airspace, eventually serving on the RTCA Board of Directors, where he was elected chair in 2022. He has also served as a member of the MITRE Aviation Advisory Committee and was elected to serve in the FAA Advanced Aviation Advisory Committee in 2019. Lorne is a licensed commercial instrument pilot, aircraft dispatcher, and air traffic controller. Lorne Cass, what a great pleasure and honor to have you on the podcast. Welcome.
Well, thanks, Jim. I'm very happy to be here.
Our first question, is there anything that very few in the industry agree with you on?
I think as we talk about new entrants, there may be very few that agree with me that noise will be an issue. I think, generally speaking, there's a thought that the new entrant operations, AAMs, eVTOL, et cetera, believe that they're much quieter and the public won't have an issue with noise. But I've been in many, many public noise meetings in neighborhoods, and for sure, the mantra today is, if I see you, I hear you. So unless it's done right, the noise people can make it very difficult to grow the market. So I would say noise may be something that people don't really agree with me on.
Well, now, isn't that something? Now, me knowing you a little bit, I'm very well aware that your awareness of community noise and the impact of the community is critical, and most people don't think about it.
Right. Well, public acceptance at the end of the day is going to be a key.
Talk about that.
Well, I think that we're doing a lot. We're seeing a lot's being done with the FAA and several of the new entrant operators, OEMs, and those that intend to operate. I think there are some areas where they've done a good job with communities. But let me just give you an example. I live out in the Phoenix area, and there's a particular homeowners association here that took a vote about 6 months ago saying there'd be no drone deliveries in our neighborhood. Now, can they just shut that off? No, but when they go to the city council and the state government and eventually the federal government, they will be heard. So I think it's really important for new entrant operators and those that plan to operate in that public arena to show the benefit and show that they will be a good neighbor.
Lorne, a lot of OEMs and operators are thinking about noise and doing all they can on the design side, operation side to minimize the noise footprint. So in what ways is your observation of this topic different in ways that people disagree with you?
Well, I would say mine goes back, of course, to the traditional aviation. That's where I've mostly been in these public hearings where they're talking about noise in communities and so forth. But the noise community is strong. And I was at a meeting just 2 years ago, an FAA-sponsored meeting on the new world of drones, AAM, and so forth. And this was out in Long Island, and there was a woman there from this noise community association, and she was adamant that I don't want to see you anywhere near my neighborhood. I don't want to see you going overhead. You tell me you're going to be quieter than what I hear today. And she said, I get that. She said, but I don't want you there because if I see you, I'm going to hear you. And that's the first place I heard that, but I've heard it several times since then. I think it's a matter of working with the public to help them understand the value in the service and the product you intend to provide.
I was just about to ask you about the value and how the perception of value will influence this conversation around noise. One of the most annoying sounds to me is the noise of the leaf blowers around the neighborhood. And they are constant, but we accept it because we get good value out of it. So how do you bring value into the discussion around drone delivery? And especially given that this is something that will benefit everyone, not just the 10% or the 5% of the population.
Right. I think you start with showing the value. So first of all, when I look at initial drone activity and drone value, I see it very much in the first responder arena, medical arena, et cetera. And I think if we can start that off and do it right, which I think there's a lot of good work going on there now, I think the public will start to accept it. And then you can expand into the neighborhood delivery and so forth. I'm sure there are some neighborhoods in the country that would have no issue whatever with drones flying up and down their street in lieu of FedEx or UPS vans doing the same thing. But I do believe it's going to take more outreach than maybe some realize through these local public entities to get people on board and to feel more comfortable with. It's new, and they'll just need to better understand it.
Lorne, the other thing that I don't think a lot of people appreciate, but when you see the noise abatement offices in the airports around the country, and you see the focus that they have on addressing every single request that comes in.
Oh my!
I still remember talking to an FAA administrator just a couple years ago, former FAA administrator just a couple years ago. And there was a question as to some people in the Boston area objecting to a new procedure for NextGen. I think it was a new PBN or RNAV procedure. And this administrator said there were a couple of people who were complaining in the Boston area about this procedure, and it didn't go through.
Doesn't take much.
And I don't know if everybody can appreciate the effects of, even though 95% of the people think it's the greatest thing.
Right.
If one or two people complain, a congressman gets a hold of that, it's possible it just won't happen. I mean, is this part of your reason why we have to pay
Most,
so much attention to noise.
yes, most definitely. And I mean, there's a good emission story to be told in most cases. I think that's a good thing for the public. But you've got to do the noise and do it right because it doesn't take much. I lived in Minneapolis for several years, and the community there is very sensitive to noise. And a lot of things that most airports should and could do, the Minneapolis airport was unable to do it because of the limitations around the community. And I can't tell you how many properties they had to end up buying in order to operate the airport. Other places, I lived in Dallas for several years. Didn't hear a whole lot of complaints around the airport there. And this is interesting too. The DFW airport specifically, as you recall, was built in the 70s, and it was built out in the middle of nowhere directly in between Dallas and Fort Worth. There was nobody complaining about noise then. However, today, the communities are built right up to the boundary of the airport. And now they are starting to see noise complaints that they never had in the past. That's relatively new, but I think a lot depends on the public, who they are, where they are, what part of the country. This area, Phoenix is generally an area that is sensitive to noise also. The airport has gone through all kinds of gyrations to accommodate the public in terms of how they fly airplanes in and out of there, and not very efficient routings, to be honest. And that is one thing they've had to live with for years in order to accommodate the noise concerns of the community. Now, did the airlines pack up and leave and go away and say, nope, we're not flying there because they're all too concerned about noise? No, they did a lot of things maybe they didn't want to do, maybe that weren't the most cost efficient, but they did it so the public would accept them and not force them to do things they didn't want to do. So I think noise will be there, and I'm not trying to say that's going to be the overriding issue, but I do think noise will be an issue in certain areas. I'll give you one example, by the way, and I would say don't confuse the noise community and the emissions community, the CO2 emissions community. And I'll give you an example. There in San Francisco, there's been a battle going on for many years to reroute departures out of San Francisco and Oakland late at night so that they fly out over the bay and then over the bridge out into the ocean. If they're going to go eastbound, let's say to New York, it adds about 60 or 70 additional flying miles. The noise community was thrilled because they've fought over this for years with the local congressional people in the room with them. Believe me, I was there. They finally implemented this, or started the implementation a couple of years ago now. And what do you think happened? The emissions community said, what? You're flying an extra 60 or 70 miles? You know how many more emissions that is per flight, every day, every night? And so the battle is there. But the noise community was happy.
Do you think that perceptions of noise change over many years, over a long duration of time? Like, what was it like when automobiles were first introduced, and were people, I'd love to see research on this.
Yeah.
Were people complaining about the noise of automobiles because it was a new sound in the environment? And that's why they noticed it and their brains didn't filter it out. But now automobiles are just part of the environment. They're part of the background. And I don't think that we have a commensurate level of noise complaints there. So I wonder in the aviation landscape, have noise perceptions of large aircraft changed over the years? Will it be a different story with these smaller things like drones? Are we going to get accustomed to them? Is the long-term arc of this one of how do we get through the introduction of this and see people start to get accustomed to it and see how the noise response behavior changes over that time?
I think it's that. I think it will take time. I've been around a long time. I wasn't around when automobiles first showed up, but I was certainly around when there were a lot of noisy jets that were flying around, really noisy jets as compared to today. And people did complain, but it was all in the way you looked at it as well. Obviously, for those of you that have ever been to a military air facility, often you would see signs that said, it's the sound of freedom. I know we're noisy, but it's the sound of freedom. When I lived in Minneapolis, my neighbor would complain to me about all the noisy DC-9s flying over our house. And I would always say to him, tongue-in-cheek, that's the sound of my paycheck. I like it. So I think it's definitely in the perception. I do believe that, I'll just say the airline industry in general, or heavy transport aircraft, have done a great job of reducing the noise, but the noise community, the serious noise community, is still out there and still complaining and just doesn't want anything near their house.
And can have an outsized impact on the FAA and different organizations with just a couple of complaints.
Most definitely. When you're at the FAA and you get letters mostly from folks in Congress that are closer to their communities, they mean something. And I've been in 2 or 3 different meetings where the local congressional delegation or the congressman or congresswoman themselves were in the room, and the FAA had to be responsive. And so did the airport authorities that were in the room as well.
What have you seen as most efficient strategies in the way that airlines dealt with community on the topic of noise, that something that maybe the drone world can learn from?
Well, I think it was a combination of not just the operator, but it was also finding community leaders that recognize the value to the community, whether it was like I said, a first responder value or a value in terms of delivering goods and services more efficiently. There's questions about the roads. I mean, obviously, traffic is not getting any better. So there are things like that I think that can be used. But in the airline world, in a lot of cases, it would be the airlines getting together with airport authorities, which are important and have a lot of community members in them, and working to see what's the best approach to the community. Having meetings with the community are very roundtable noise meetings, and a lot of these airports are important. I think the future operations to and from airports will already have a start in that area in terms of if you're going to fly a eVTOL or whatever. I think you're going to have a good start because they're already going to have some mechanism for doing that. If you're going to fly to a vertiport that's downtown, whether it's on top of a building or someplace downtown or out in the sticks in an area that has not typically had, I'll put this in quotes, aircraft around it, I think you're going to have to go out, find the local community leaders, introduce yourself, and say, we want to be a good community member and participate and show the value of what we deliver. I think it's really important to get those people in the room as quickly as you can.
Lorne, terrific. All stemming from those things that people don't agree with you on. Tell us a little bit about, you have years of experience in the airline industry. Give us an overview of the industry based on your experience and also the evolution of technology during that time.
Well, the technology has evolved quite a bit. I mean, when I started in the industry, the very first airline I worked for was a very small airline that operated DC-6s and Lockheed Electras. And that Electra was leap years ahead of the DC-6 in terms of how fast it could go, where it could go, and so forth. And of course, now today we're flying much more modern transports. They get from A to B much quicker. They are much more reliable than it used to be. When you think of reciprocating aircraft engines and the reliability, I mean, they were reliable, but they required tons and tons of maintenance, lots of moving parts, literally. And so that has improved dramatically. The aircraft themselves have improved dramatically. In terms of managing them from an ops control perspective and operations for an airline, the technology has moved very much away from literally teletype. Teletype was around in sending messages on aircraft movements in many places until just 10, maybe 15 years ago at the most. Still there. Obviously, when we were able to send messages more directly using computers and email and so forth, that changed it. The tracking mechanisms for the aircraft, it used to be when the aircraft took off, the pilot knew exactly where he was. The dispatcher was tracking him, just like air traffic control in many cases did, by manual position reports given by radio. Can you imagine that today? That still happens over some of the long transatlantic flights and so forth. So I would say, and something you've been involved with, certainly, Jim, is surveillance. When we first talked many years ago, all I wanted from the product you had, I wanted to know where my airplanes were. It was important to me. It was important to me to be able to be more efficient in figuring out if the guy that was number 10 in holding, if I wanted to get him out of holding first by coordinating with ATC. But in the past, I wouldn't know, and he wouldn't know. He wouldn't know if he was number 1 or number 21 in a holding stack, for example. So I think the knowing where the aircraft are and what they're doing, the data that are exchanged is huge. The data that's exchanged in terms of the efficiency of the airspace operation is also huge. So almost 30 years ago now, the FAA and airline industry got together and talked about, well, what if we exchange data? So we better understand, we have more accurate, more predictable times. So for example, if American Flight 123 is scheduled to depart at 0800, but the airline knows because of a passenger connection issue or crew issue or whatever it is, it's really not going to depart till 0845. There was really no good way to pass that along. You had about this 2-hour window around your proposed time, but then came along collaborative decision making out of this, where we started to exchange some of those things. So you can imagine initially when we, the airline community, were working with the FAA, and there were 3 airlines that started this off, exchanging very basic data with the FAA, and they would in turn sort of exchange it with the other participants, so you have a better picture of what was going on at LaGuardia, what was going on at Minneapolis, what was going on in Dallas. And this collaborative decision-making effort came out of that. Now, I can promise you, in the first few years of, it's called CDM, in the late 90s, going and telling my boss that we were going to share information, and I put that in quotes, with, for example, our competitor United Airlines or Delta Airlines, that didn't go over very well. What? No, we're not. We're not sharing it. We're not telling them what we're doing. But when you work through it and understand, if everybody gives better information, more accurate information on what they're actually doing today and when they intend to operate, whether this is an airline, by the way, or general aviation, business aviation primarily, it makes a huge difference for the entire national airspace in terms of operating more efficiently. I would say today it's about, I'll call it surveillance for a loose term. Where is my airplane right now? I also want to know where it's predicted to go. We can do that with some of today's tools. But I also want to be able to exchange the appropriate data very quickly and very reliably in order to improve the operation for everybody. And that's coming more and more.
And when you think about the introduction of the new vehicles, and you think about data sharing, what kind of advice would you give to them, that things that they're going to have to anticipate that they may not be thinking about today?
Well, I think it's important to understand that. So I have heard a few new vehicle type operators, and I would say this is primarily among the drone community, say things like, we'll just separate ourselves. Okay, but I think that's probably possible. However, once you start operating in airspace where there are other operators, and if they're also saying, well, we'll just separate ourselves, and there's a third operator that says, well, we'll just separate ourselves, at some point, you're not going to be separating yourself. So there's really going to be a need to exchange that data, track data, intent data, and so forth, so we can all live together more efficiently. Can you imagine the airline industry if everybody was separating themselves and the only way that they would change the track is if they got a TCAS warning that says turn right and descend immediately? Same thing in the drone community. It wouldn't be very efficient if you were operating, let's say, drone delivery service and didn't know that somebody else was out there, and you're altering your course multiple times to avoid these other vehicles. I mean, at some point it would be, you'd stretch the system too far. So, but if the other guy knows there's somebody here and we can figure out a way to share better, I think that makes a lot of sense. This airspace is finite. It's big, but it's finite. And we have to figure out a way to share it with everybody in a much more flexible, much more dynamic way.
So to that end, we want to talk about airline operations just a minute with your deep experience there. So we're obviously seeing a lot of growth, a lot of demand in the airline and the air travel area. How do we bring capacity to the system to account for that continued growth?
I think, first of all, there's a lot of fingers that are pointed at the FAA for not being quick enough to move forward. I think there is some truth to that. However, they have masters that work up on that big hill in DC and respectfully work for them. And a lot of times, programs that they have underway are interrupted, not purposefully, but interrupted by deliberations on the Hill that could have nothing to do with that particular program, but affects the, I'll just say, the stable flow of the financing for the FAA. So I think the number one thing we have to do is make sure that the FAA stays as the entity it's been for years, as the North Star for safety and efficiency for the world airspace, if you will. And I think a lot of that's going to really depend on finding a way to ensure they have stable funding mechanisms. And I think you probably heard that from my good friend, Mr. Rinaldi, who you talked to a few months ago.
And Lorne, can you talk a little bit more in some greater level of detail when we look back at how technology helped accommodate increasing demand on the national airspace system, how that was achieved, whether through greater surveillance or better management of the traffic, various technologies along the way, and then projecting into the next couple of decades where people forecast the doubling of air traffic. How will that be accommodated? Any particular technologies that you're excited about or see the potential in?
Well, I think there are a lot of technologies that are coming to bear, just not quick enough. So, for example, like the FAA's communication system between facilities and so forth is still today largely a wired system. And the facilities that the FAA uses in the U.S., I'm going to use that as an example. If you think of the number of centers, there are about 20 centers in the United States. And they date back to the Cold War. And when decentralized facilities seemed a very good thing, because if there was some sort of an attack in one place and not the other, you could still have these decentralized, these places that could sustain on their own without having to be connected to anything else. But the world has changed dramatically from then, and the way data can move, is moving, and is moving towards, is in a much different fashion. And the FAA is trying to move there, but it's not easy. And remember, they are very concerned about the reliability and redundancy of any system they deploy, because they're protecting airspace and they're protecting vehicles from running into each other and loss of life. So they're very keen on their number one goal, which is safety. Efficiency is secondary, but once we do a better job of exchanging these data and surveilling the airspace, and the surveillance has improved dramatically. When I started as an air traffic controller many years ago, there wasn't a digitized target. So when I saw a target on my radar, what I saw was a target, if you will, a blip, as people like to say, but I saw a target. And I had to, in my head, know who that was, and I had to know what I was doing with the airplane, what its speed was, what altitude, and so forth. In the mid-'70s, in the center environment, they came forward with digitized radar, which for the first time used multiple radar sites feeding into a digitizer, and it actually created a target on a radar screen. And I could see the identity of the aircraft, destination, type aircraft, speed, altitude, etc. That was a huge leap forward in surveillance. That same sort of surveillance is still there today. It's still overlaid, so all these systems overlay into one or another, so I can use 4 or 5 radar systems to get a much more accurate picture of where the aircraft is going. I can use GPS as well. So I have much, much better, much more accurate surveillance. Communication systems with the airplanes from the ground to the airplane are slowly changing, and the controller pilot data link system is coming on board now, and it's, I would say, in the center environment, it'll be out there over the next 5 years or so. I think most of the centers will be in the CPDLC environment. Many of them are already there and moving there. And that will make a difference, because that will help with, I'll call it, routine communications. So when you're passing from one center to another, rather than the controller saying, clicking the mic and saying, Delta 126, contact New York Center on 12345. Have a nice day. And then the pilot coming back and saying, Delta 123, we'll do the same. See you. Bye-bye. It'll be sent digitized, like a text message, like they've had for years with ACARS. ACARS from Air Inc. has been in airplane cockpits for many years. And airlines have been able to communicate with their aircraft using digital messaging, but air traffic control has not. So that type of thing is going to make a huge difference, as well as tools that for the future are going to do a much better job of not only saying, here's where we are, but here's where things are going. And I'm talking about in real time. So more predictive information around tracks. We've already had, in the last 10 or 15 years, the ability for these conflict probes using this digitized radar to look out for a controller, let's say, that's working in Denver Center, and say, hey, if you don't do something, United 123 and Delta 425 are going to have a problem up here in 20 miles or so. And the controller could then take some sort of corrective action to change the track or the altitude on one or the other. So those things are getting more and more efficient. I think in the future, and there's some of this already going on, we need to do a better job of collecting data every day for every operation, whether it's a bad weather operation or it's a perfectly beautiful day, and pull that all in and analyze it, and then use what I see as a value of future AI in the future for air traffic control, for example, is then learning from the last event we had and make sure we don't do something that gave us a problem on the last event in the next event, and doing that fairly quickly. I hear some people talking about AI should be the first thing out there in terms of safety, but I think we need to wait until it proves itself before we have it being the primary safety tool. That's my own thought. So really, I hope that sort of answered your question. I think where we've come from is good. Where we're going is good. Getting there in between is difficult. When NextGen was first announced by Russ Chu back in 2005 or so, one of the problems with NextGen is they got a name called NextGen, and everybody expected on January 1st, 2020, everything was going to be fixed. It just doesn't work quite that way.
Are there lessons from the rollout of CPDLC that help inform what our expectations should be for the rate of adoption of these other things?
Well, I can't speak to all the issues with CPDLC, but I can tell you, I'll give you an example. So the gent I just mentioned, Russ Chu, came from American Airlines before he went to the FAA. And American was very heavily involved in Miami Center in testing CPDLC on a number of aircraft with the FAA. And he was a very strong supporter of CPDLC and what it did. He then was at the FAA, and a couple of years later realized that the FAA simply did not have the funding available to roll out this capability. I think they were originally planning at 3 or 4 centers along the East Coast. And he didn't put the program on hold, but he had to stretch it out a lot farther. And again, that kind of goes back to, do they have a stable funding mechanism that allows them to react to these things and keep things moving forward rather than be sidelined for a while? The FAA, many times on these programs, when we have a government shutdowns or whatever, they have to stop everything they're doing. And imagine if they had a program that had 2 prime contractors and maybe 30 subcontractors. All of that work stops. So if I'm a little subcontractor with 10 people and my funding is stopped and I have no idea when it's coming back, I may in fact have to lay off people. And maybe some of those are really critical people. And when we start up again in 3 or 4 or 5 or 6 months, that person I let go that I really needed is working for somebody else or gone someplace else. So you can imagine how the pylon effect that occurs. And CPDLC, I think, was caught with that because it was very promising, and it's taken many years, longer than originally thought, to get it out there.
Lorne, let's talk a little bit about airline operations. Tell us, what's the goal? What's the impact on the airline, its financials? Tell us how an airline operation runs.
Okay, so let's talk about what's important to the airline. First of all, they provide a customer service, and they're in business to make a profit, like any company that's in business. First of all, they have to develop a schedule. It's going to be a scheduled operation, which most of them are scheduled operations. And they have to be able to deliver safe and reliable service. And those are the key things. So if you think about an operations control center, they are in fact responsible for that day-to-day operation of the airline in real time. And things change in real time. And I would say to any new operator that plans to be out there in this world, that you can plan on something happening you never expected in a million years will happen. And you have to be prepared to react and prepare for it and so forth. But for an ops control center, the most important thing is safe, efficient, reliable, and obviously financially sound operations. So what they're going to look at in most cases, their key metrics are completion factor. That means how many flights did I cancel, or hopefully none. My departure performance, let's just call it on-time performance. So departure performance, for most airlines, they measure it from what they call D0. D0 simply means departing on schedule. My schedule said I was going to depart at 13:05. I departed at 13:05, not 13:07, not 13:20. D0 performance. Then obviously arrival performance, because that's really important to the airline as well as to that customer. The customer may be going to a meeting that day, maybe going to visit Aunt Sally, or maybe trying to make a connection at that airport. So that arrival time is very important. And that's one of the metrics, of course, that's critically important to the DOT when they're providing overview. And then, of course, they need to look at what they call their block time performance. In other words, if they planned that this flight from Detroit to Denver was going to take 2 hours and 1 minute, how reliable are they? If that's what they planned in their schedule planning, how good are they at hitting that 2 hours and 1 minute? So they measure that in what they call block time performance. And you don't want your block time performance to be too high, because you're paying everybody involved, that airplane crew and everything else, based on what you show as the planned block time or anything over that. So let's just say that if you plan 2 hours on that stretch and every day you are actually flying it an hour and a half, it's costing you that additional 30 minutes for let's just say the crew time, as well as over the course of a day. If your block time performance is too high, you are wasting an aircraft by the end of the day. So if it was 30 minutes on every leg and that airplane flew, let's say 8 legs, you might have been able to fly another complete flight with that airplane. So how good did you plan the performance of that airplane? So the advanced planning and then obviously the post-ops analysis are critical for some of the reasons we mentioned earlier. Let's look at what we did yesterday and see if we can do this better tomorrow. Does that make sense?
It does. Two things real quickly. One
Mm-hmm.
is, if you know it takes only 90 minutes to fly, why is your block just not 90 minutes every day?
Well, I think because there are some days where it might take you, if it's a 2 hour block, there might be some days where you take 2 hours and 14 minutes or 2 hours and 22 minutes, particularly on a busy route that has a lot of, I'll just say, uncertainties around ATC or other issues. So you may pad that block because you know, in order to get that A14 that you want, the on time arrival, you may need to pad that a little bit so that you can be more assured that you're going to hit that A14. Now, if you look at today, in my view, if I look at airline block times today, they are much higher than they were, let's say, 15, 20 years ago, because the system is not able to support some of the level of demand that's out there. And airline CEOs are much more cognizant of the focus on airline cancellations and on-time performance. So sometimes they'll pad that block, but it costs them money to pad it.
Now, I understand that some level of padding or sandbagging
Mm-hmm.
of this block time is necessary, but
Mm-hmm.
what would it take for the entire system to get more lean as it relates to block time? Is that even possible?
Is it impossible? No. I think it just depends on where the focus is, and the focus seems to change now and again. I think as we get more efficient with using airspace and some of these new capabilities and technologies come along, I think the block time will automatically start shrinking down to a more acceptable level. I can tell you that I worked for one boss at an airline, a large airline, Jim's familiar with it, that he wanted block time to be at somewhere around 65%. That's low. Today, when I look at block times,
Explain 65%.
in other words, 65% of the time is acceptable in reaching that 2 hour block, if that's what I had planned, rather than 85% of the time, because it's cheaper. And again, I'm not a guy that builds block times, and I'm not familiar with every single thing that goes into them, but a lot of it has to do with crew, aircraft, where's that airplane going to be, the lines of flying that they build, and so forth. Today, I would say I see several airlines that are at least 10 points above that, which is a lot. And some of them that are actually in the 80s, which means maybe they planned a day that they expected they were going to be, because of the time of year, the time of week, or whatever it was, that there were going to be typically a lot of delays, and none of them materialized. So all of a sudden their block performance goes up dramatically. A lot of the block padding has to do with, I think, in my humble opinion, in the inefficiencies in the operations today. Hopefully we can improve in the future.
So if somebody comes and pitched you a better way of predicting off block time or just broadly improving on-time performance, how would you evaluate this technology? How big of a lift would it be to include that in the entire sausage making machine, for lack of a better analogy, to actually make an impact at the end of the day?
Well, I can tell you, I had a lot of people in my office over the years that had this great idea that was going to solve all my problems. Usually it was one thing that was going to fix everything. I'll say this first. What I found sometimes, many times, is whomever and whatever they were trying to sell, they weren't asking me what I needed. They were telling me what they thought I needed. So I think that's one thing that a lot of companies, and there are lots of good things going on out there today in order to improve the operation in real time and take shortcuts and routes and so forth. Some of those are all good things. Any little minute or two you can save here and there is really important. Other things happen to be, can we do a better job of predicting weather? Many years ago, I had somebody from a very large company with a very large weather service that came in and told me they could give me 48 hours notice as to when a thunderstorm would impact one of the outer arrival fixes, let's say, to this big airport. And I was pretty certain that was not possible. We did a test for a summer, and it was not even close to possible. I said, if you can predict that 4 hours in advance, I'd be happy, much less 48 hours. So I think that it is about data. There is a lot of work going on today in terms of collecting data and then presenting it to an airline in a usable form. There are a couple of airlines, including one I'm quite familiar with, that have done a lot of really good in-house work in understanding and evaluating in real time what's going on with the operation and what's the best way to react to it. For example, if there's a big weather event that goes through, I'll just say DFW, and they have 70 diversions, all right, in the past, maybe it was just, okay, we got to get those airplanes back. There was not a lot of thought put to prioritizing getting those airplanes back, other than sort of from seat of the pants, this dispatcher or this ops coordinator knows that this particular flight's got 80 connections. And all that occurred, but that occurred in a manual fashion. Today, there are technologies that are pulling all those data together and then saying, here's how you should recover these diversions, if that makes sense to you. But that type of thing, we need to get better at doing that.
You mentioned something very interesting that nobody really asked you what you needed at the time. What are some of the things that you needed then? And importantly, what are some of the things that the industry needs today? What are some of the main frustrations when it comes to running airline operations?
Predictability really is the number one thing. So whether it's an internal, first of all, you have to really understand the condition of the airline internally as an airline. What's going on with my aircraft, technical issues, airport issues, crew issues, spare aircraft issues, because all of those things ultimately are going to impact my customer. And at the end of the day, my customer is what impacts my bottom line. So those are the things internally I have to know. Externally, I have to have a much better idea and much more predictability for what is happening today in this airspace system in which we're going to operate. Because once I get the wheels in the well of an airplane, it's out of my hands. There's a lot of other people involved. Obviously, the crew are involved. I promise you that the dispatchers in these big airline ops centers are coordinating with the crews and giving them updates, real-time information for something that's going to occur 300 or 400 miles in front of them. So there's a lot of good exchange of information that's going along. In terms of that, trying to pull in all that together with all the operators that are out there that are relying on this same airspace, this very finite airspace, we need to share as much information as possible so we can all use it most efficiently. And that includes, by the way, the military, who I have a great deal of respect for the military. And of course, their missions are changing, but they have a tremendous amount of airspace that they use every day for training and so forth. And sometimes it's available, but the FAA and operators don't know it's available. So if you could imagine, if you're flying from Dallas to Los Angeles, you go right through New Mexico where the White Sands Missile Range is located. There's an airway that goes right through the middle of White Sands Missile Range. And it's usually closed because there's something going on in White Sands Missile Range that they don't want you flying directly over it. So that means you either have to go to the south, around the very south end of the White Sands Missile Range, which means you're over El Paso, or roughly over the north end, which means you're over Albuquerque. So that adds extra time and fuel and CO2 emissions that may not be necessary if you only knew that airway, J65, was actually available and you could have flown through there. Now, there's a lot of work in that area to make it more dynamic and predictable and improving the data exchange between DoD and FAA so that they each know, they have a much better idea of when this airspace is going to be available, making it more flexible and usable so others can use it. But we're still not there. Predicting what's going to happen is really important. So I can understand, like I said, from the very beginning, I can predict what is going to impact this particular flight. But I also need to understand what may be impacting the FAA and what may cause me an issue farther down the line. I also have to have a very close eye on my customers and what I'm doing or not doing that can impact them. But it's still at the top of the list would be, give me data that I can use to make my operation more predictable. And predictable doesn't mean that I'm going to depart every day on my schedule at 0800. It means that I know that I'm going to have to factor in a delay of 23 minutes for that flight as early as possible.
When it comes to dealing with unexpected circumstances, whether this is weather, rerouting, ground delays, or any number of things, and somewhere I've heard that about 15% of total fuel is wasted on these kinds of inefficiencies. But dealing with these inefficiencies, is that currently done mostly by human expertise, intuition, or to what extent is technology being used, and certainly some things on the horizon that you're excited about?
Well, I would say, yes, it has been mostly done by human experience, intuition, and so forth. That has been changing, and it's changing for the better. And as more information are available to these humans, more data are available, I think that's going to improve that efficiency. You are right about the amount of fuel that's carried. Let me give you an example. Go back to that military airspace. Let's say I was planning a flight from Dallas to Los Angeles, and I knew that J65 would be open. I wouldn't have to put that additional fuel on that airplane, which would allow it to fly around the corner on the north or south end, for example, of White Sands. Even if I'm en route already in carrying this additional fuel, I can save some. If they open it up while I'm flying, I can go through there. But the reason it's important to know ahead of time in that case, and there's where some of this technology today and some of the data that are exchanged are going to be exchanged in the future, I hope, between DoD and FAA, will allow me to plan that from the very start. Because in some cases, if I'm on a route, let's just say around a weather area or a military area, whatever it is, and it's a long reroute around that area, then I have to put extra fuel on the airplane to do that. And then somehow when I get the wheels in the well, I'm flying, and the controller says, oh, guess what? That area is opened up now. You can go direct to Miami. And I take a direct route. In some cases, I have to go into holding and dump, if I can, most airplanes can't these days, or burn off fuel to get down to the landing weight, because I could actually be over my maximum landing weight because I have too much fuel on the airplane. So predictability there again is a key. If I knew that ahead of time, it wouldn't have been a problem.
Lorne, you said something about the FAA, knowing about the intentions, the behavior of the FAA. What is it? Why is that important? And what kind of information do you need? And what needs are there that potentially could be met by technology firms?
I think there's already some technology firms that are helping them meet that. And I think there are technology firms that are helping airlines and operators better understand what may or may not happen. It starts in many cases because weather is usually one of the biggest things that impacts the throughput in a given chunk of airspace. I think the forecasts are getting better and options are getting better. I think there are several small companies that are really good at pulling this together, aggregating all these data, and presenting it in a way to an airline that they can better understand it. I think in some cases, and this is why the CDM is so good, because as I said, a lot of the dialogue around what we're going to do today in the NAS occurs every 2 hours with a phone call between airline operation centers. NBAA also has a desk that stays involved. AOPA has a desk to better understand what's going on. But there's an exchange of information there as well. Some years ago, when I was at Northwest Airlines, Northwest had a very well-known and well-thought-of meteorology department. Not everybody had one, but I'm just using them as an example because I was there. And often our FAA colleagues at the FAA Command Center would ask the Northwest Airlines meteorologist for what their prediction was for weather in a certain area, to compare that with what the FAA had received from NWS, and then try to pull those things together and come up with a good plan. And that's not just, I'm saying it wasn't just that airline. There's other airlines that have their own meteorologists, bigger airlines do. That was an exchange of information that was very good. But I think there are small companies, as I said, some of them that are looking out today and working with airlines. 2 or 3 airlines have contracts with some of these folks to help them better plan a route of flight based on what they know, at least at that time prior to departure, that they can plan a better route. And then when they're en route, to help them find a few shortcuts here and there, save 10 miles here, 10 miles there, because some constraint that was there, be it weather or otherwise, traffic management initiative, for example, didn't materialize, and they can save a few minutes. Minutes is fuel is cost, and fuel burn is obviously emissions, which are critically important. I would say a lot of folks, by the way, and I've even suggested to some of these small companies for years, up until pretty recently, they would talk about fuel burn and fuel cost savings, and they're certainly there. But today, you really need to work right into that first sentence when you're selling green. This has an emissions benefit, because it does. Fewer emissions, if every minute you don't have that engine burning, is obviously fewer emissions. So that's important.
Lauren, when thinking about ways to improve throughput in the national airspace system, spacing of aircraft comes to mind. Can you talk about how spacing is done today and what the main limiting factors are and ways that can be improved in the future? One thing that comes to mind is voice-based communication. The throughput limits on that channel and all of the limitations associated with it are compensated in, among other ways, in spacing out aircraft, perhaps more than it might be possible. So to what extent is that limiting the spacing, and how do you see technology improving that aspect of operations?
Well, I think technology, in my humble opinion, could have already improved some of that over time. So I'll give you an example. I mentioned before that many years ago, when the center environment went from these single site broadband radars that looked out 200 miles each, and the farther away you got from the antenna, the bigger the target got, and all those kind of things. So in the en route environment, 5 miles separation between aircraft was always the mantra. That was the requirement, 5 miles. Because of the fact that you could get so far away from the antenna and the target would actually grow in size the farther away you got. When the digitized radar came along, all of a sudden you had a target that was always one uniform size, and it was fed by multiple radar sites. So it was a pretty accurate positioning of that target. There was a discussion at that time in reducing that separation to 3 miles, but it didn't happen. And in the terminal area where there's a single radar site and it's looking out 40 miles and not 200 miles and turning at a much faster rate, that 3 mile separation has also been there for some period of time. Now, there is work going on today, not to reduce separation, but to use tools on the aircraft, for example, to do a better job of managing the spacing. So that if I'm looking at the airplane in front of me, and I'm in the following aircraft, and I can see who it is, where they are, what their speed is, and so forth, and I'm needing to maintain separation there, I might be able to do that. I'm not separating myself, I'm managing the interval. And that's important because when you start saying to a controller or even to a pilot that you're going to, and I'll use these words loosely, self-separate, that's not a good thing. Because then it comes down to one of the things we'll talk about at some point. Who's actually responsible if something goes wrong? Responsible, who has the authority, who's going to be held accountable. But the good news about this interval management, which is being tested in 2 or 3 places and is very promising, is interval management may help us reduce the separation. And I'm talking now about longitudinal separation, obviously, between aircraft. Vertical separation, which is essentially 1,000 feet between aircraft, until, I guess it's 20 years ago now, hard to believe, until reduced vertical separation minima came about. When you were above about 30,000 feet, you had to be separated by 2,000 foot intervals. Below that was 1,000. And that changed to 1,000 feet. And there was a lot of concern about it at the time, but it worked very well. And that was based on better equipment in the aircraft, more accurate altimetry, and so forth. So I do think that this interval management work that's going on is probably going to help us at some point get to reduced spacing between aircraft longitudinally.
Lorne, in a few minutes, we want to start talking about how you evaluate technology firms that come to you. Now, you've already mentioned one is first ask what the airline is looking for rather than just telling you about your capabilities. But let's say you gave us an overview of the airline, you gave us an overview of the airline operation, you talked about the complexities, you talked about the importance of predicting what's going to happen, which runs a better operation. So let's now say we have 10 or 15 new entrants in the market 5-10 years from now. Let's say eVTOL, let's say you have drone air delivery operations at Dallas and a lot of different locations. And given your experience in operations, what are some of the things that excite you and what are some of the things that concern you? And what advice would you give to somebody who is running those operations?
First of all, I would say that, first and foremost, I would say that it's very important that they understand the FAA role. And I think it's important that they understand that the FAA is many different divisions and departments and so forth. And I know, for example, at one point, a CEO made a comment to an individual that I know that said, well, this is 2 years ago now, by the way, it's not recent. 2 years ago, he said, well, we talked to the FAA and they really like our concept, so we don't see any problem. And the question back to that CEO at the time was, which FAA did you talk to? And he was a little bit taken aback by that. And the comment was, look, anyway, they talked through this and determined that it was somebody in the FAA certification office. And so he was told, well, the certification person is looking at your vehicle and saying, does it look like it can fly? And from what he or she saw, yeah, it looks like it'll fly. But there are many more steps, 7 or 8 more steps, till you actually are in a position where you have a vehicle and you have a paying customer on board that vehicle, most especially. So I think I would say that's the one thing, to try to better understand the FAA and how they work and so forth. And I think there's some of the new entrants that are out there, I think, are doing a pretty darn good job of that and are pretty well known in the FAA headquarters building and the FAA arena. Others probably could do a little more in that area. But I think they have to think about, for the future, let's say eVTOL operator, AAM operator, they have to think about the vehicle, they have to think about its limitations. They have to think about how do they track what it's doing? How do they operate it in real time? If it's a network they're operating, once they have 2 or 3 vehicles out there operating and something happens with one of the vehicles where it can't operate, how are they going to win? What are their contingencies for doing that? What kind of redundancy do they have built in? And I think there's a lot of that needs to occur with the new operators.
And Lorne, when it comes to technologies that people use in airline operation centers and broadly in those corner of airlines that are involved in running the operation, ensuring a smooth operation, how often do the technologies there get updated? And when we think about the innovators in our audience, the entrepreneurs, what are the best pathways for new technologies to get in there and be adopted?
I think, first of all, you have to visit and you have to see and understand what these airline operation centers do, how they work, and so forth. I think that they also need to understand the airline's customer. And I think everybody's flown somewhere, so you know what it's like to be a passenger on an airplane, but the airlines probably have some prioritization of customers. You're going to have certain customers that travel often, expect something a little bit higher than others. So I think understanding the airline customer would be good. Going and actually sitting in one of these airline operation centers. Don't go in and say, I have a great idea. Go in there and say, I'd like to learn more about your business because I think I have some ideas that might be helpful in the future. There needs to be a little more of a merging, and not just at the commercial level, because a lot of the new operators are working with airlines in the commercial level. That's really good. And I'm talking about in the chief commercial officer and that kind of arena. That's good. But if you're talking about actually operating your network, I think you need to make sure that you take that, if you've got that connection, and get it over so you can watch and see how an airline operates every day. And depending on what you plan to do in the future, if you may be operating under, say, Part 135, and you may be carrying 4 or 6 or whatever it is passengers, the FAA is going to require you to provide, I'll put it in quotes here, but it's important, operational control of your aircraft and your network as you operate it.
And in your experience, how often is new technology introduced?
Well, that's a hard question. There's been a ton of new technology that's been introduced over the years. I can tell you that some of the technology, let me just use flight planning systems that airlines use, are only recently, within the last 2 or 3 years, starting to update and do a better job and pull in more data than they have in the past. So the foundational airline operating systems that have flight planning capabilities probably go back to the late 70s. I mean, to the mainframe period. And again, I'm not somebody who built the original ones, but I can tell you they work, they're reliable. They did not give me efficient flight plans. And a lot of times, dispatchers that work in airline operation centers, and dispatchers, by the way, are the ones that actually produce the plan for each individual flight. And with the captain, they both have to sign off on that flight. They both go through the flight plan and they both agree, yep, this is a safe operation, we can do this, and they both sign it. So they have joint responsibility for operational control of that flight. The flight planning systems and the routes that are available today, in some cases, the flight planning systems of old can't really file the most efficient routes without a tremendous amount of manual intervention by a dispatcher to, quote unquote, build a route. Some of the newer systems, and there are a couple that in this country and a couple from abroad, that do a much better job of smoothing that and finding a more efficient route and being able to flight plan that more efficient route that the aircraft FMS can operate and understand. There are efficiencies that are out there today in the NAS and globally for more efficient routes that some flight planning systems simply can't do. So that's moving forward. The other thing is there are larger needs for the, I'll call it the operation of the airline in real time, other things that tools have helped with. And I'm talking about with, for example, crew. Where are my crew? What are my limitations on my crew? Where are my airplanes? Okay, this airplane is flying 6 segments today and it's going to have maintenance, so I'm going to have to plan that. All that in the past has been done. At some time in the past, this is quite a while ago, that was plotted on a plot board, like you see on an aircraft carrier maybe or something. Those are now highly automated, or much more automated than they were in the past. They need to get a little bit better, and those are the kinds of things that airlines, I promise you, are interested in. Some are, as I said, doing a lot of good work in-house. Others are going to third parties to help them build these systems, but they're looking for a way to better understand. They want the whole picture. So they want to understand weather forecasts. They want to understand what's the best Planned departure time, even if my schedule says 0800. What kind of gate availability do I have? What kind of crew availability do I have? What kind of customer connections? How about the ATC demand and capacity I see out there? What about IROPS recovery if I need it? And then how do I plan for the FAA's traffic management initiatives and getting the information in the right way? The FAA provides a warehouse called System-Wide Information Management, where it's a data warehouse that's available for airlines to use. Some airlines can't use it efficiently. They can only get a little information. So there are small companies that are coming out and helping the FAA to better use those data.
Lorne, let's make a little bit of a shift to something you just brought up as it relates to demand and capacity. And let's talk a little bit about the choke points. We've discussed it in some of our recent podcasts. Give a sense for where you see the choke points today in the world and what's being done about those choke points. So first, where are they? And two, what are we doing about it?
You mean other than New York?
Right. Is there anything other than New York, right?
Well, New York obviously is a very complex chunk of airspace. It has been for many years now. You got 3 major airports there that are all very busy in terms of commercial operations. And then you have a couple or 2 or 3 of the, I'll call them smaller business or general aviation airports, but they are very busy. The airspace is compact and extremely complex. The people that work there in terms of the FAA and the controllers and so forth really deserve a pat on the back for what they do every single day, because that is one tough nugget in terms of complexity of the operation. So if you have a disruption, whether it's weather or a runway closure you didn't expect or something else, I mean, it backs up the system very quickly. I saw a depiction a few years ago that was done by MITRE, and it was of an airplane that flew from, I think it was flying from Chicago to Newark. And as it approached Newark, the runway closed and it had to go into holding. And that meant the airplane behind that one also had to go into holding. And that meant the next airplane had to go into holding. And then that backed up across from the New York Center into the Cleveland Center, where the New York Center controller said, hey, I can't take anymore. I got all these airplanes going into holding because I had this runway issue. And so Cleveland Center starts holding airplanes. And then at a certain point, Cleveland Center backs up and says to Chicago Center, hey, you've got to hold airplanes. So before you knew it, holding within about a 40-minute period backed up from New York all the way to Minneapolis Center. And in fact, the runway closure opened again in about, I think it was about 30 minutes, maybe a little bit less, but it caused that backup that quickly. So it's a huge choke point. And there are so many airplanes in the airspace, there's only so many places you can go with them. The other thing is, because of the complexity of the airspace itself, the New York approach control, if you will, that handles all the airports close in, has above it New York Center, which handles airplanes from, say, let's say, 18,000 and above. And then to the north, you have Boston Center. To the west, you have Cleveland Center. To the south, you have Washington Center. All the movement of aircraft that have to move because of weather or whatever, it requires coordination with all those facilities. So imagine today how many phone calls it takes between those facilities to coordinate just some of those simple moves. So I would say New York is still very complex, and a hiccup can cause a lot of problems in a hurry, and it's understandable. And people that work there in those facilities, the controllers I'm talking about, and at those airports, they have their hands full every day with a lot of traffic and a lot of things that one hiccup can really back up things quickly. Other choke points that I see today, of course, you've read about the Florida issues that are occurring. Part of that has been blamed on controller staffing, particularly at the Jacksonville Center. I do think that is a factor, but I also think just the general demand into Florida and the fact that it's a peninsula and offshore of Florida into the northeast and to the northwest are big military training areas, and the fact you have Cuba right to the south. So it's really a limited chunk of airspace to move a lot of airplanes. And if you have any sort of hiccup, like thunderstorms do occur in Florida, it really backs things up very quickly. And the growth in traffic there, growth of air carrier traffic, as well as general aviation and business traffic, is pretty significant. And it just can't handle all the stuff that's going on if there's any sort of a constraint on that given day, be it weather or if it happens to be controller staffing. I think other places where there's just been so much growth that there are issues. I look out at Las Vegas. Las Vegas is very busy and getting busier. And the airport there, the main airport, of course, McCarran, and that has been swamped on many days. It's got a lot of limitations. It's got crossing runway issues, close parallels. So I think those are what I think of as the main choke points. You also have the kind of the more traditional long-range choke points, which would be some of the oceanic stuff, particularly in the North Atlantic, but that's, I think, maybe operating better than it used to. And then you have the old traditional places like Chicago, which just has volume of airplanes and has issues with different airports there. I mean, Midway and the big airport at O'Hare operate close to each other. There's a lot of other airports. Atlanta kind of sits by itself, but it has a ton of airplanes. DFW, the Dallas-Fort Worth area, is growing dramatically. So you will see from time to time issues down there. They usually run pretty well. I would say if there's anything that happens to them, it's thunderstorms, particularly those that evolve in the spring and early summer that come off of the plains and meet with all that nice moisture from the Gulf of Mexico. So those are the main choke point areas.
And what are we doing about them? What's the technology that's being deployed and will be deployed?
Well, right now, I think that the airlines have been asked to pull back their schedule a little bit in the New York area because of the demand, because of some of the issues that they have going on there. They have just recently announced that finally, after it's been about a 3-year effort, they're moving, I'll just call it the Newark sectors out of the New York TRACON, which is known as N90. They're moving that over to the Philadelphia approach control. So the Philadelphia TRACON is going to take over the airspace that controls arrivals and departures out of Newark. There's a lot of pushback on that. A lot of it was from controllers that didn't want to relocate. There were some technology issues initially, but those were solved. This is new equipment, and it'll play very well. I know this will shock you, but there were also some political issues there with moving the facility. But it sounds like now they're moving in that direction very quickly, and they finally made a decision that the move would be completed by the end of June. But this has taken about 2 years, so nothing happens quickly. All of those airports in New York, as you know, Jim, I'll say surface management there, I'm going to go to that because I know that area very well, has been a work in progress since, 2007, 2008. And what we saw in New York was often flights would taxi out and sit in queues. I have a picture that I still have today. It got my attention because it was at Kennedy Airport. And because there had been a runway closure and they were down to a single runway operation, and because the system still operated at the time, still does for the most part, on a first come, first served basis, you push back because you don't want to get left behind. You want to first come, first serve. There are 63 airplanes in a single taxi queue for the departure runway. And because of other issues, many of them sat out there for hours, literally. In some cases, I know of at least one flight sat out there in the taxi queue for departure long enough to serve the dinner meal on the aircraft. And that just seemed to be crazy. So with that, first of all, came surface surveillance to know who was out there, to really better understand what was going on. And then I'll call it virtual taxi queues, metering aircraft off of the gate. And Kennedy was one of the very first airports to do that. And it was in conjunction with the FAA, the airlines, and the Port Authority. And what that meant was you would tell the port and the FAA what time you plan to push back. You provide a pushback time estimate. And then they would give you an actual time that you had to be they didn't tell you that you have to push back at this time. They would tell you what time you had to be, what the FAA calls is the movement area of the airport. In other words, off of the ramp, wanting to get onto the taxiway. And they were able to very quickly, within months, dramatically improve taxi times and delays and so forth. And most important, improve predictability. Because in a pure first come, first served environment, not very predictable. You just go out there and get in a long queue and sit there. There was some work that was planned at LaGuardia back in 10 years ago that didn't happen then. It is starting to happen now through the FAA's Terminal Flight Data Manager program, which is basically surface management, including surveillance and times, much more accurately. TFDM is important, and I was very much involved in that in my return to the FAA some years ago. Unfortunately, the program, which was, I would say, envisioned in the 2005, 2006 area and actually signed off on, the concept was signed off in 2011, 2012, because, again, of these interruptions in budget, where it was originally planned to be pretty much rolled out and ready by the early 20s. Several airports around the country, a long list of them, quite honestly, now is probably going to be 10 years delayed. And I worry about that because I worry about some of the technology in this program. It will probably be obsolete by the time the program's rolled out. but it will still make a difference compared to not having it. That's for certain.
And the quantifiable value of TFDM service management is so significant. The return on investment was so high. But Luca was asking one of our guests recently about the role of gates and the role of surface. And so there's some, I remember once at an investor conference, and a CEO said, I don't have an air traffic problem. I have a gate problem. What did he mean by that?
Yeah.
As it relates to increasing the throughput of the number of passengers going into an airport?
Well, if you operate on time, and at some airports, let's say you own gates. Let's say pick an airline and I own 10 gates at an airport. I'm responsible for those gates. So if I have a disruption, let's say I've got a flight that has a maintenance issue and is not going to depart the gate at 2:00 as scheduled, it's not going to be able to leave until 3 or later, but I have an arrival that needs a gate or that gate. I got to figure out what I'm going to do. Am I going to move that aircraft off the gate? Am I going to try to arrange for another gate? How do I handle that? But I own it, so I can make those decisions. In some cases, I may have an airport where I'm leasing gates from the airport authority. Let's say I have those same 10 gates, they're leased, and those are the gates I have to use. I may be able to use another gate that is suitable for my aircraft on another terminal, or maybe down the road from where I am, down the terminal from where I am, and maybe I won't be able to do that. So gates are huge, and understanding for the airline, using some of the data that we have started to collect, for example, through TFDM with this, I'll call it the virtual taxi queuing, estimated off blocks times, for example, maybe have a better idea how my gate availability is going to occur. But I have to plan that and there's a whole bunch of reasons. I can't just take any gate sometime, because maybe any gate doesn't work well for me in handling the aircraft when it's on the ground. Maybe it doesn't work well for my customers that have close connections. I don't want to be over in Terminal D when my customers have close connections in Terminal A. So I've got to be able to manage that. So gates are critical. Some of the newer technologies that are out there, including a couple that have been developed in-house, take the gate availability into the mix of the overall schedule and overall irregular ops recoveries and so forth. And that's a huge deal.
It's so important for people to understand this level of complexity in the air, on the surface, and at the gate, and the number of different technologies that are used, the information sharing that takes place, and actually, frankly, the role of some really small companies that are making great innovations in this area. So for those that are listening, you're hearing an industry expert talk about great opportunities for optimization and improvement. And some are doing a good job today, but there's a lot of opportunity for technology deployment here, isn't there, Lorne?
Yes, there is. And there is a lot of it being deployed. And I would say those that have the expertise, there's a lot of opportunity out there. And I think there's a tremendous amount of opportunity in the new world of AAMs. If you think about what they're going to need to do, and if you think about a vertiport operation, that's going to have to be another one of those things. Because I know it's hard to believe, but your operation is not going to be operating exactly as you planned every day. Some days it'll work really well, and other days it won't. And you may end up showing up at the vertiport when there's no place for you to park. So all those things have to be factored in.
Lorne, you were known in the industry as somebody who, if you want to bring new technology to an airline, see Lorne first. And then what advice would you give to our entrepreneurs? There's billions here to be saved and to be optimized with more efficient operations. And then you can imagine the opportunities with advanced air mobility coming online. What advice would you give to an organization that they think they have a pretty good technology, and they've been told to go see Lorne Cass to see how should I really bring this to market? What advice would you give them?
Well, call me and I'll tell them.
right.
Yeah. Okay. Fair enough. Again, going back to, they've got to develop a relationship with the operator of this particular vehicle and learn from what they're doing. And when you're talking about to the new entrant operators, you need to use some of the things that have been learned in the airline world. And the airline world is still learning and has a lot to learn yet, like many other businesses. But it is done much better at using available capacity that it has control of. And that's important. But it needs to have a better understanding of the stuff I can control as the operator and things I can't control. Like I said, as soon as my vehicle moves, everything. Think of it this way. The airline industry is deregulated. I put that in quotes. And the AAM operator, for example, eVTOL operator, is also going to be, quote unquote, deregulated. But the fact is, as soon as you put that vehicle into the airspace, you are in a highly regulated environment. And anything that you can help the operator learn about different constraints that are going to impact the operation that will allow him to operate more efficiently in that highly regulated environment from takeoff to touchdown is going to be very important. In addition to that, you need to pull in all the things around that airport operation or vertiport operation, whatever it is. But go to them, and first of all, as I said, listen, ask them what they think they need. Ask them how they use tools today that they might be able to use in this new AAM world. I'm talking about if you go talk to the airlines, but I think it's going to be an important place to go and understand how they manage this. And you're going to have to help them because there's going to be a need for clear rules of responsibility and lines of authority and accountability. You have to help them with those things. And I can't repeat that enough. Remember, responsibility, authority, and accountability is going to be required by not only the FAA, but by your customers.
One of the common frustrations that we hear from people who are trying to push new technology into the airline industry, even for things that are relatively easy to fix, the lower hanging fruit around air traffic management. Everybody broadly recognizes that there is maybe an opportunity to improve the efficiency of the overall system by 10, 15% perhaps. But the common frustration is that you're dealing with so many different stakeholders, different nations, integration with IT systems that are very fragmented, that are very old, very fragile. And hence you're talking to an audience that doesn't really have the appetite to change things in fear of risking potentially even a worse outcome. What strategies, what kind of advice would you have for those people to circumvent some of those issues?
Well, those are big issues. And I do think that the new operator, the AAM, if you will, I think that they're going to start off, in my opinion, the starting role for them is going to be in serving, I think, high value customers of a given airline or airlines. And I think that's going to mean more of the stuff that's going to be fairly close in, pretty well defined. In the longer term, when you get to the vehicles with a higher capacity and range, then I think some of that regional operation makes sense as well. So I think and I heard Mr. Rinaldi say the same thing, and I agree with him. I think now some of the operators, those that are getting closer to operating, recognize that you're going to have to go in and use the ATC system as it exists today to start. That means you're going to be flying things like helicopter routes and so forth. As you prove your operation on those routes to yourself, to your local airport, vertiport, whatever it is, to the FAA and to your customer, and show that you can operate those reliably, then I think there'll be an opportunity to expand. There's airspace today that could be utilized. The other thing I think that I do believe has to be looked at is at the airport itself. If you're operating to or from an airport or a vertiport, you have to fully understand what it's going to take to turn the vehicle. You also have to understand irregular operations. And so, for example, if your vehicle carries 4 people and has a payload of 1,000 pounds, you're going to be right at max pretty much. And then most of these vehicles are electric. So range is important. And I see some that advertise a range of X number of miles, but I look at them and think, gee, what kind of reserves do I have? Because the operation's not running the way I thought it was going to run, and I'm delayed, I'm behind, or I have to divert because of some issue. What can I recover this vehicle if I divert to some other place? How does that work? So I think there are a lot of things the operators themselves, the OEMs and the operators, in many cases will be one and the same initially from what I can see. I think they have to take all that into account. And maybe they are and maybe they're not, but there's things I worry, for example, about icing. I hear many operators say, we won't fly into icing. My response is, yes, you will. And you have to be prepared for that and understand how your vehicle is going to deal with it. And there's just other things for customers and so forth. I thought, Jim, the gent you had on that was talking about the G-forces and elevator design, how that might impact the eVTOL world. And I thought that those are the types of things that have to be thought of.
Yeah, it's terrific. Lorne, are there any questions that you were hoping we would ask that we haven't asked that you'd like to talk about? Any other topics?
I would say this. So I think it's important to these new operators to get as involved as they can in the world of CDM, in the world of standards, be in the room, and many of them are, but get in the room and work on things like standards are going to be very important. And standards are not good standards unless they're built by consensus and collaboration. And I think that there are several different standards organizations that you should go out and get involved with, because I think that will help you. And when you go into those meetings, by the way, whether you're in a standards organization or you're at a CDM meeting or something similar, or even going and sitting in on one of the Advanced Aviation Advisory Committee meetings in the audience, you're going to learn. You're going to learn from other people in the room and realize that you don't know everything. And go listen to some others that have some experience in the arena or have been there before.
So you're going to be seen.
And you're going to be seen. Yes. And there's a lot to that. If you're okay with Acme eVTOL service deciding the way you're going to fly, then you don't need to go. But I think if you want to understand what they're going to do and you want to learn from that, and maybe they can learn a little bit too, I think that exchange is really good. Be in the room, be present, and be an advocate for your organization.
Give us a couple of the standard organizations you think they should be part of.
Well, of course, I'm affiliated with RTCA. So RTCA is the oldest aviation standards organization, and they have many different bodies and many different working groups. Some of the sessions are plenary. There's a lot of public stuff. You can just look them up online. ASTM is another one. Just done a lot of work in the arena. SAE, but those are the three big standards organizations that I would suggest. And they've already done a lot of good work around eVTOL, drones, autonomy, and so forth, and obviously more to come. But if you're in the room and being heard, it's a really good thing.
Luke and Peter, any other questions for Lorne?
Not from this side.
I'm good too. This was a really interesting conversation. Thanks a lot, Lorne.
Lorne, just terrific. You were everything you were billed to be, and a great wealth of knowledge for our existing and for our new entrants. So thanks a lot, Lorne.
All right. Thank you, Jen.
Thank you, Lorne.
Okay.
Thank you.
Bye-bye.
Bye-bye.
All right, that's a wrap for today. Thank you for listening to the Vertical Space Podcast. Reach out if there are topics that you would like us to discuss, and goodbye until the next episode. Unless mentioned, this podcast is in no way endorsing or promoting any person and or company mentioned, and all opinions within the podcast are solely that of the presenters. The Vertical Space makes no guarantees, warranty, or representation of any information given in this podcast. Any information given is for informational purposes and should be used at your own risk. This podcast is for general, educational, and entertainment purposes only.